Okay, it feels almost silly to record a single video for problem 9c, but whatever. So the question is a primitive matrix? Well, a primitive matrix is a matrix is primitive if all entries are greater than or equal to 0, or not negative. Check. And if a power of the matrix has all entries being strictly greater than 0. Well, also check, because the matrix itself is the matrix to the first power, and all the entries are strictly greater than 0. So yes, A is primitive. Another example, just to make sure everyone's cool with this, is, for example, if, say, the matrix was, I don't know, if it was upper or lower triangular. So if you had something like, I don't know, 1, 0, 2, 3, or 3, 2, 0, 1. These matrices are also both primitive. If you look at B, so first of all, they meet the first condition. All the entries are non-negative. They're greater than or equal to 0. And the second condition, well, if you square either of these matrices, B squared is 1, 0, 2, 3 times 1, 0, 2, 3. And when you multiply them together, 1, 0 with 1, 2 gives you 1. 1, 0 with 0, 3 gives you, let's see. Oh, maybe not. Maybe it's not primitive. I think I might have made a mistake. It's not primitive. It's all right. 1, 0 with 0, 3 is going to give you 0. 2, 3 with 1, 2 is going to give you 2 plus 6, which is 8. And 2, 3 with 0, 3 is going to give you 9. So that matrix is actually not primitive, right? Because even though all the entries are non-negative, a power of it, well, I should say this power of it still gives you a 0 there. And you can kind of see that any power of it, you're still going to get a 0 in that upper corner. So let me give you a different example. Let me switch that as. I believe this matrix is primitive. So if you look at C squared, which is 3, 2, 1, 0 times 3, 2, 1, 0, you're going to get, let's see, 3, 2 with 3, 1 is 9 plus 2, which is 11. 3, 2 with 2, 0 is 6. 1, 0 with 3, 1 is 3. And 1, 0 with 2, 0 is 2. So there's a matrix that is also primitive because all of the entries are non-negative and some power of it has all positive entries. So worth noting, an upper triangular matrix like this, where everything above the diagonal is 0, or a lower triangular where everything below was 0, would actually be not primitive because powers of it would still not give you everything being positive. Okay, so that's that about primitive matrices.